Welcome back, class. We just finished our conversation on encoding. Now let's talk about storage. Retaining information in the brain. Topics to keep stored in your brain. How we hold stories in storage, the explicit memory system, frontal lobes, and the hippocampus. How we retain responses and procedures, the implicit memory system, cerebellum and basal ganglia, the amygdala, emotions and memory, flashbulb memories, and how synapses change to help store memories, long-term potentiation. Memory storage, capacity, and location. The brain is not like a hard drive. Memories are not in isolated files, but are in overlapping neural networks. The brain's long-term memory storage does not get full. It gets more elaborately rewired and interconnected. Carl Lashley showed that rats who had learned a maze retained parts of that memory, even when various small parts of their brain were removed. Lesson: memories are not files found in a single location or locations. Explicit memory processing. Explicit declarative memories include facts, stories, and meanings of words such as the first time you were riding a bike or facts about types of bicycles. Retrieval and use of explicit memories, which is part of the working memory or executive function, is directed by the frontal lobes. Encoding and storage of explicit memories is facilitated by the hippocampus. Events and facts are held there for a couple of days before consolidating, moving to other parts of the brain for long-term storage. Much of this consolidation occurs during sleep. Without the hippocampus, we could not form new explicit memories. The brain stores reactions and skills, the implicit memory processing. Implicit memories include skills, procedures, and conditioned associations. The cerebellum, the little brain, forms and stores our conditioned responses. We can store a phobic response even if we can't recall how we acquired that particular fear. The basal ganglia, next to the thalamus, controls movement and forms and stores procedural memory and motor skills. We can learn to ride a bicycle even if we can't recall having the lesson. Infantile amnesia. Implicit memory from infancy can be retained, including skills and conditioned responses. However, explicit memories, our recall for episodes, only goes back to about age 3 for most people. This nearly 3-year blank in our memories has been called infantile amnesia. Why? The explanation: encoding. The memories were not stored well because the hippocampus is one of the last brain areas to develop. Forgetting and retrieval. The adult mind thinks more in a linear verbal narrative and has trouble accessing pre-verbal memories as declarative memories. Emotions, stress hormones, and the amygdala in memory. How does intense emotion cause the brain to form intense memories? 1. Emotions can trigger a rise in stress hormones. 2. These hormones trigger the activity in the amygdala. 3. The amygdala increases memory-forming activity and engages the frontal lobes and basal ganglia to tag the memories as important. As a result, the memories are stored with more sensory and emotional details. These details can trigger a rapid, unintended recall of the memory. Emotions in memory. Flashbulb memories refer to emotionally intense events that become burned in as a vivid seeming memory. Flashbulb memories are not as accurate as they feel. It is possible there's an evolutionary function here for this type of memory, these vividly strong memories, because they may store information about dangers and may help our ancestors to survive. Why the term flashbulb memory? It's as if a camera's flashbulb goes off when our mental photo was taken of an event, brightening the picture. Maybe this term will need to be updated since cameras no longer have noticeable bulbs anymore. Why is it vivid seeming? These memories may feel vivid as if we were re-experiencing the event, but they are not necessarily accurate. In fact, they get altered every time we recall them. This change can make the memory worse or it can make it a good thing. Trauma therapy depends on this reconsolidation. Brain processing of memory, synaptic changes. When sea slugs or people form memories, their neurons release neurotransmitters to other neurons across the synapses, the junctions between the neurons. With repetition, the synapses undergo long-term potentiation. Signals are sent across the synapses more efficiently. Synaptic changes include a reduction in the promoting needed to send the signal and an increase in the number of neurotransmitter receptor sites, as we can see below and to the right. Messing with long-term potentiation. Chemicals and shocks that prevent long-term potentiation can prevent learning and even erase recent learning. Preventing LTP or long-term potentiation keeps new memories from consolidating into long-term memories. For example, mice forget how to run a maze. Drugs that boost LTP help mice learn a maze more quickly and with fewer mistakes. So a summary of the types of memory processing. On the left we have automatic. Implicit memories, non-declarative, happens without conscious recall. Processed in the cerebellum and basal ganglia. Such things as space, time, and frequency. Motor and cognitive skills, and classical conditioning. Memory processing to the right, effortful processing. Explicit memories or declarative memories with conscious recall. Processed in the hippocampus and frontal lobes. Cover such things as facts and general knowledge, as well as personally experienced events. Now let's talk a little bit about retrieval. Getting information out of storage. Topics you should be able to retrieve in class or on an exam. Retrieval cues. Priming, triggering which memories get used. Serial position effect, primacy and recency effects on what is most easily recalled. Context independent and state dependent memory. Why it's good for you to take your exam in the same room, in the same mood you're in now. So let's look at memory retrieval. Recall. Some people have the ability to store and recall thousands of words or digits, reproducing them years later. Recognition. The average person can view 2,500 new faces and later can notice with 90% accuracy which ones they've seen before. Relearning. Ebbinghaus found that it was easier to memorize nonsense syllables the second time around. Some memory must have helped with his relearning of the syllabus. Recognition test. What is this object? You've seen it already before. Even though it is obscured by 6 layers of scribble lines, those of you who glanced in a corner of the first slide of the chapter may recognize this. Any simple multiple choice question is also a recognition test. Retrieval cues. Retrieval challenge. Memory is not stored as a file that can be retrieved by searching alphabetically. Instead, it is stored as a web of associations: conceptual, contextual, emotional. So memory involves these web of associated concepts. Priming. Retrieval is affected by activating our associations. Priming triggers a thread of associations that bring us to a concept, just as a spider feels movement in a web and follows it to find the bug. Our minds work by having one idea trigger another idea. This maintains a flow of thought. Prime example, define the word bark. Now, what is the definition of bark? The power of priming. Priming has been called invisible memory because it affects us unconsciously. In the case of the tree bark versus the dog bark, the path we follow in our thoughts can be channeled by priming. We may have biases and associations stored in our memory that also influence our choices. People primed with money-related words were less likely to then help another person. Priming with an image of Santa Claus led kids to share more candy. People primed with a missing child poster then misinterpreted ambiguous adult-child interactions as kidnapping. So what this tells us is that we can be primed, which allows us to more easily access certain types of memories, or maybe even influence us to perceive certain types of events. Now, let's talk about context-dependent memory. Part of the web of associations of a memory is the context. What else was going on at the time we formed the memory? We retrieve a memory more easily when in the same context as when we formed the memory. Did you forget a psychology concept? Just sitting down and opening your book might bring the memory back. Words learned underwater are better retrieved underwater. So as you can see in the graph below, if you have different contexts for hearing and recall, you can see the amount of words, percentage of words recalled, like around 20% or so. But if you learn the words while you were underwater and recall them while you were underwater, you can see the percentage goes up drastically. Same thing for land-land pairing. So greater recall when learning and testing contexts were the same. Context-dependent memory. State-dependent memory. Our memories are not just linked to the external context in which we learn them. Memories can also be tied to the emotional state we were in when we formed the memory. Mood congruent memory. refers to the tendency to selectively recall details that are consistent with one's current mood. This biased memory then reinforces our current mood. Memories can even be linked to physiological states. Looking at the cartoon, I wonder if you'd mind giving me directions. I've never been sober in this part of town before. Somewhat in bad taste, but you probably get the point. And then we have the serial position effect. Priming and context cues are not the only factors which make memory retrieval selective. The serial position effect refers to the tendency when learning information in a long list to more likely recall the first items, called primacy effect, and the last items, called recency effect. So what we see here is the following. We see a graph of percentage of words recalled. From a list of words, you can see the position of the words. The bluish line, later recall. Only first items recalled well, and that would represent the primacy effect. Immediate recall. The last items were remembered best. So the last items on the list are the ones that are recalled more regularly. This is the recency effect. So looking at the percentage of words recalled, primacy versus recency effect, we seem to see a stronger effect when it comes to the recency effect.